Dear CDT supervisory academics, I appreciate this opportunity to share my research project. It is truly my honor to introduce it to you. Due to our limited time, I will just pick one project that closely relates to my current research field and to Dr. Wen Fengxia's lab I'm applying to at KCL. Also, this is my current postgraduate project in Dr. Jiaji's lab at Duke University. The title is Extreme Heat on Placenta Health and Birth Outcomes with 2D Array PCD System and Designed Mice Model. In this study, we hypothesized that perinatal exposure to extremely high temperatures will lead to hyperperfusion, evaluated oxygenation, and subsequent adverse birth outcomes. We have two goals for this project. First, we will characterize placental hemodynamics in response to daily and extreme heat exposure, which is 40 degrees Celsius for 2 hours during critical gestational windows in the murine model, accessing blood flow and oxygenation across early, mid, and late pregnancy stages. The second goal will evaluate birth outcomes and postnatal developments, monitoring parameters such as birth weight, litter size, and neurobehavioral matrix in offspring. Currently, I mainly focus my work on the first aim, and my collaborator, who is a doctor from medical school, contributes to the second aim. However, I'm present at every stage of the study. All the results I will show you after this are all created or acquired by me. I've spent approximately more than 3.5 months of work since we proposed this idea in the first place. We expect a paper coming out before I graduate from Duke and the expansion paper aiming for higher impact journal in the future. The first job I did for this project was to design and build a completely homemade heating chamber from scratch. As you can see, I have heating chamber 1.0 all along to 3.0. The upgrades include capacity, from 1 kg capacity to maximum 3 kg capacity, and increasing comfort and convenience in use. For I'm not the only one who will use the chamber. I must think about my collaborator as well. So I emphasize on whether this chamber can be operated by one person independently in the design of 3.0. Regarding the functionality, I had PDC heater and humidifier mounted to provide 40 degrees Celsius and 50% humidity for the heating group and 25 degrees Celsius for the room temperature group. Also, I have baseline humidity and temperature provider, and I'm currently using a commercial PID control system. The self-designed PID chip is in progress. Although our project schedule is still under careful consideration, I can show you the schedule I proposed during our meeting recently. The chronic study, I put 4 groups of mice which would be sacrificed at different time points for my collaborator to do the histological test. Then I will keep one set of mice just for imaging. Similar things will happen during the Q study, only to point out that each group will be heated and imaged once before we set up. Now it's time for us to see some imaging results. We are here to see the placenta for now, right? So I need to know how, where, and when to find it. These are all SO2 MAP of one of the control mice from E12 to E18. This MAP is the maximum amplitude values of signals along the depth projection. The orientation of this mice is as if the mice is facing us and belly up just like necropsy. We circled the placenta based on the B-mode image, which I will show you later. There is no confidence in E12. The placenta in E15 starts to reveal itself to us. I also tried to image just one focused embryo here. The placenta I circled out was identified and with the help of my collaborator and her PI, who are both doctors. Here is the placenta vascular structure I found from a paper as reference. Why am I putting this page here? You shall see it now. This is the compared result of E15 PA, B-mode, and SVD, which is singular value decomposition ultrasound. From B-mode, we can see the baby's spines, and SVD image gave us clear view of a broadly-shaped vascular structure circled out. I used clues from ultrasound images to help me locate the position of the placenta back to the PA image shown on the left. The videos here are the corresponding single slice video. As you can see, to gain the B-mode and SVD images, I actually do the post-processing to the matrix, including get rid of the surface signal and the signal from deep in the belly to show the spine clearly. Similar things will happen in E18. This time we have additional clue from necropsy. Still, we can observe obvious broccoli-shaped structures. We believe these are the placentas. After we figure out where and how to find placenta, we are now in the middle of preparing a acute imaging test. However, due to the 2D array system has the problem of scanning speed, our collaborator suggests us to find a faster way to do quick PA imaging. With the help of one of the senior PhD students, I learned to use the DAT system he built before to acquire fast scanning results, PA and B mode only. I will do the imaging at the beginning before water circulation starts as a control group, and then I will open the water circulator, taking 10 minutes for the water temperature inside the holder to rise up to 40 degrees Celsius and stabilize. Then heat the mice for another 30 minutes. I will do the imaging with the same scanning setting again as the heating group. Here are the compression results of my first DAT system test. As we can see, the oxygenation level does change a lot between the control and heating groups, and I think it can correlate with the necropsy results shown at right that my collaborators did before. However, there are still many questions to be asked. For example, I need to add another set of compression tests to weed out the effect of prolonged anesthesia on SO2 results. Similar analysis would require another in-depth discussion with my seniors and professors, but this result is still motivating for all of my group. To improve our 2D array scanning speed, with the guidance of my senior PhD lab member, I developed the method of fast scanning using our 2D array system. By modifying the lab wheel setup, now I can finish a whole body scan of a single wavelength in less than 3 minutes, with similar imaging quality. Here is the result of 730 nanometer imaging. The placenta part is circled out by blue oval dashed line. Those bright marks on top and bottom are from black Sharpie I drew on the belly of mice to help me identify my region of interest. After I get rid of the surface signal, those marks are gone as shown in the right images. These are the volumetric videos of PA results of 730 and 870. This is the SO2 MAP from the results I've shown above. I've marked the location of the placenta with a yellow rectangle. The zoom out images are shown on the right. We believe these parts are placentas. I also upgraded the heating holder design for the 2D array system acute test I'm using right now. This self-made holder with 3D printed PLA frame, copper plate, and laser-cut acrylic window are designed to deliver stable temperature rising and maintaining function and safe ISO air pass for the mice. This is the end of my presentation. I still have a lot of exciting projects that I cannot cover today, including my TeraJet project and my endoscope designing projects. If you have any questions, please feel free to contact me later. Thank you for this opportunity again.